Today in geometry, we are going to look at lateral area, surface area, and volume of cones, cylinders, and spheres. So first, let's talk about what is a cylinder, a cone, and a sphere. So a cylinder is a solid with congruent circular bases that lie in parallel planes. The height of a cylinder is the perpendicular distance between the bases. The radius of a base is the radius of the cylinder. In a right cylinder, the segment joining the centers of the bases is perpendicular to the bases. The lateral area of a cylinder is the area of its curved surface. The surface area of a cylinder is the sum of the lateral area and the area of the two bases. So this is a picture of our cylinder. This would be the height of the cylinder. This is my base. This is another base. At the center out is the radius. The lateral area of a cylinder is still P times H, the perimeter, since the perimeter of a circle, okay, that's like our circumference. So that's 2 pi r and then times the height. The surface area is 2 times the area of the base. The area of a circle is pi r squared. So 2 pi r squared plus our lateral area. The volume of our cylinder, the area of a circle, pi r squared, times the height of the cylinder. So now we're going to talk about a cone. So a cone has a circular base and a vertex that is not in the same plane as the base. In a right cone, the slant height is the distance between the vertex and a point on the base edge. So in this picture over here, you see this is our radius. This is the height in the middle of our cone. That's the height of the cone. On the edge out here, that is our slant height. Slant height is represented with an L. Okay, so the lateral area of a cone, the perimeter of the circle times the slant height. So that's going to be pi times r times L. Surface area of a cone, the area of the base, so pi r squared plus 1/2 the circumference times the slant height, so plus pi r L. Volume of a cone is 1/3 pi r squared times h. Now we're going to talk about a sphere. A sphere is a set of all points in space that are a fixed distance from a fixed point. That fixed point is called the center of the sphere. The distance between the center of the sphere and any fixed point on the sphere is known as the radius of the sphere. A chord of a sphere is a segment whose endpoints are on the sphere. The diameter of a sphere is a chord that contains the center. If a plane intersects a sphere, the intersection is either a single point or a circle. If the plane contains the center of the sphere, then that intersection is known as a great circle of the sphere.
And then we have a graphic.
The circumference of the great circle is the circumference of the sphere. Every great circle of a sphere separates the sphere into two congruent halves called hemispheres. All right, so if we look at this, the surface area of a sphere is 4 pi r squared. So here's my sphere, here's the center, here's the radius. Volume of a sphere, 4/3 pi r cubed. This picture shows the great circle. Okay, so this is the great circle, the diameter, the radius, the center, and then what a hemisphere looks like. All right, so now we're going to practice some examples. Find the lateral area, surface area, and volume of each. So number one, I want to find the lateral area. I have a cylinder. So my formula says 2 pi times my radius. They gave me my diameter. If my diameter is 14, then my radius is half of that, 7. So times 7 times the height, 28. We're going to leave these in terms of pi, so we're not going to multiply 3 by pi. So we're going to do 7 times 2 is 14, times 28, 392 pi square meters. The surface area is 2 pi r squared, so 7 squared, plus our lateral area, 392 pi. When we work all of that out, we get 490 pi meters squared. Volume is pi times our radius squared, so 7 squared times the height of the cylinder, 28, which is 1,372 pi meters cubed. Number 2, we have a cone. In our cone, remember that we're going to need the height of the cone. So this 13, that's on the edge, so that's my slant height. My diameter is 10, so that means that my radius is 5. This is going to be my height. So I need to do Pythagorean theorem. So h squared plus 5 squared equals 13 squared. So h squared plus 25 equals 169. So h squared equals 144. So my height is 12. So now let's find lateral area. Lateral area of a cone is pi RL. So pi times our radius 5, our slant height 13. Again, we're going to leave this in terms of pi. So I would get 65 pi square feet. Our surface area, pi times r squared, so pi 5 squared plus our lateral area is 65 pi. We work that out, we get 90 pi square feet. Our volume, 1/3 pi r squared, so pi 5 squared times the height of the cone, which we found to be 12. Work all that out, we get 100 pi cubic feet. So now we're going to look at a sphere. Okay? A sphere does not have lateral area, only surface area. In this sphere, they told me that the diameter was 25, so my radius is half of that, 12.5. So my surface area is 4 pi times my radius, 12.5 squared, which is 625 pi square centimeters. My volume of a sphere, 4/3 pi times my radius, 12.5 cubed. Multiply all of that out, we get 2,604.2 pi cubic centimeters. Number 4, again, we have another sphere, no lateral area. Surface area is equal to 4 pi times our radius, 4 squared. So 64 pi square centimeters. Our volume, 4/3 pi, our radius, 4 cubed. Gives us 85.3 pi cubic centimeters. Number 5, we have an oblique cone, right, which remember just means it's tilted or slanted. We need to find the slant height. This is the height of the cone. We need our slant height. Okay? So if I look at this triangle, this is 16, this is 9, we need L. So 9 squared plus 16 squared equals L squared. So 81 plus 256 equals L squared. So L squared is equal to 338. So my slant height is the square root of 338. And remember, I can just leave it like that. Our lateral area of a cone, pi times our radius, 9, times our height of, times our slant height, the square root of 338. When we multiply that out, again, leaving it in terms of pi, we get 165.5 pi centimeters squared. Surface area, pi times our radius squared, 9 squared, plus our lateral area, 165.5 pi. All of that gives us 246.5 pi square centimeters. And our volume, 1/3 pi r squared times slant height 16. Multiply all of that out and we get 432 pi cubic centimeters. So our last page of examples, we're going to look at word problems. So number 6, an orange juice can is a cylinder with a base diameter of 7.2 feet and a height of 13.5 feet. Find the area of the label. So they didn't tell us what type of area we have to find. We have to figure that out. Okay, so we have a cylinder. Diameter of 7.2. So that means that my radius, if I cut that in half, my radius is 3.6. The height is 13.5. We want to find the area of the label. Okay, again, we've talked about this. If we're going to put a label on the cylinder, we don't cover the top. We're only covering around the curve. So this is lateral area. So we need to know if they ask me to find the area of the label, they're asking for lateral area. So lateral area of a cylinder, 2 pi times my radius, 3.6 times my height, 13.5. So that is 97.2 pi square feet. Or if I actually multiply through by pi, I would get 305.4 square feet is the area of that label. So that is a really big orange juice can. Number 7, the diagram shows a section of a concrete drainage pipe, which is in the shape of a hollowed out right cylinder. To the nearest cubic centimeter, how much concrete was used to make this section of the pipe? So see, we have the outer pipe, and then we have the inner pipe. So first we need to find the volume of the big cylinder. So pi times the diameter of the great big cylinder is 48, so my radius of that is 24. So pi times my radius, 24 squared, times my height, 52. That gets me 29,952 pi cubic centimeters. Now we're going to find the volume of the inside cylinder. Pi, my radius, the diameter of that one is 44, so my radius is 22. They both have the same height, so 22 squared times 52, which gets us 25,168 pi cubic centimeters. They hollowed it out, so that means that they took this out. Right? All of that got taken out. So the volume of my pipe is the volume of my big cylinder, 29,952 pi, minus the volume of what was inside that got taken out, 25,168 pi. All of that gets us 4,784 pi cubic centimeters. Multiply all that through by pi, that's approximately 15,029.4 cubic centimeters of concrete that was used to make that drainage pipe. The last example, find the volume of the empty space in a box containing 3 golf balls. The diameter of each golf ball is 1.5 inches. So this is 1.5, this is 1.5, this is 1.5. The box holds the 3 balls, so that means that the box is 1.5 inches deep. If I add 1.5, 1.5, and 1.5 up, I get 4.5 inches for the length, and the height of it is also 1.5. The radius is going to be half of 1.5, so 0.75. So if I want the volume of the empty space, so this empty space in here is what I'm looking for. So first I'm going to find the volume of the box itself. That's my rectangular prism, so the volume of that, 1.5 times 4.5 times 1.5, which gets us 10.125 cubic inches. Then I'm going to find the volume of one of the balls. They're shaped like spheres. So that would be 4/3 pi times my radius, 0.75 cubed, which is about 0.5625 pi cubic inches. Now I want the volume of the 3 balls, because there are 3 of them in there, so 3 times 0.5625 pi gets me 1.6875 pi cubic inches. I'm going to go ahead and multiply that through by pi, and I get approximately 5.3014 cubic inches. The box itself will hold 10.125 cubic inches. The 3 golf balls inside, the volume are 5.3014 cubic inches. So the volume of the empty space is equal to the volume of the box, 10.125, minus the volume of the 3 golf balls, 5.3014, gives us approximately 4.8236 cubic inches of empty space. So that takes care of lateral area, surface area, and volume of cylinders, cones, and spheres. Tomorrow we will look at pyramids.